On November 23, 1943, at 21:45 hours, Japanese Transport Minister Admiral Shimada Shigetaro stood in the operations room of the Imperial Navy Ministry in Tokyo, studying a map covered with red pins marking merchant ship losses. Each pin represented a vessel sunk by American submarines. The pins had been accumulating steadily since December 1941, but the pattern had changed dramatically in recent months. What had been scattered losses across the Pacific had become systematic destruction of Japan's entire maritime logistics network. Shimada's staff had compiled the monthly loss reports. In October 1943, Japan lost 43 merchant ships, totaling 261,000 tons. In September, 39 ships totaling 172,000 tons. In August, 32 ships totaling 157,000 tons. The trend was accelerating. Japanese shipyards were building replacement tonnage at maximum capacity, but construction rates were falling behind loss rates. The arithmetic was simple and catastrophic. Japan was an island nation that imported 80% of its oil, 70% of its iron ore, and 60% of its food. Those imports traveled by merchant ship across sea lanes now patrolled by American submarines that were sinking vessels faster than Japan could replace them. Shimada understood what the red pins meant. They meant Japan would lose the war not through battlefield defeat, but through economic strangulation. The shooting would continue for another 21 months. Millions more would die. But the outcome was being decided in the depths of the Pacific Ocean by American submarine commanders who were methodically destroying Japan's ability to sustain industrial production, feed its population, and fuel its military. The question that would haunt Japanese naval planners was both simple and unanswerable. How did American submarines become so effective when German U-boats, which started the war with superior technology and doctrine, were being defeated in the Atlantic? Germany entered World War II with the most sophisticated submarine force ever assembled. 57 operational U-boats, all modern designs, supported by 2 decades of clandestine development that had circumvented Versailles Treaty restrictions. German submarine doctrine emphasized pack tactics, night surface attacks, and aggressive prosecution of merchant shipping. Admiral Dönitz had refined these tactics through years of theoretical study and practical exercises. He calculated that sinking 800,000 tons of Allied shipping monthly would cripple Britain's ability to sustain its war effort. His calculations were based on careful analysis of British import requirements, shipping capacity, and construction rates. If Germany could sink ships faster than Britain could build them, Britain would be forced to surrender regardless of military outcomes on land. The strategy nearly succeeded. In 1942, German U-boats sank 1,400 Allied merchant ships totaling 7.8 million tons. That exceeded any previous year's shipping losses in history and represented more tonnage than Britain and America combined could replace through new construction. The crisis was so severe that British food supplies dropped to levels requiring rationing that reduced civilian caloric intake below minimum nutritional requirements. Oil reserves declined to 30 days' supply. American troops and equipment could not cross the Atlantic in numbers sufficient to mount offensive operations. The Battle of the Atlantic appeared to be turning decisively in Germany's favor. Then everything changed. Between May and September 1943, Allied anti-submarine warfare capabilities improved so dramatically that U-boat losses became unsustainable. In May 1943 alone, 41 U-boats were sunk. Dönitz withdrew U-boats from the North Atlantic convoy routes in acknowledgment that losses exceeded sustainable replacement rates. The turning point resulted from multiple technological and tactical improvements converging simultaneously. Allied escort carriers provided air cover over previously undefended mid-ocean gaps. Improved radar allowed surface escorts to detect U-boats at night when they had previously attacked with impunity. High-frequency direction-finding equipment enabled convoy commanders to locate U-boats from their radio transmissions and route convoys around wolfpack concentrations. Increased numbers of escort vessels allowed for persistent prosecution of contacts rather than brief attacks before returning to convoy protection duties. The combination proved devastating to German submarine operations. U-boats that surfaced at night to recharge batteries and attack convoys were detected by radar and attacked before they could dive. U-boats that transmitted position reports to coordinate wolfpack attacks were located through direction finding and subjected to concentrated air and surface attacks. U-boats that attempted to maintain contact with convoys for extended periods found themselves hunted by escort groups that could pursue contacts for hours or days until the submarine was destroyed or forced to break contact and withdraw. Germany responded with technological improvements, including snorkel breathing tubes that allowed submarines to run diesel engines while submerged, acoustic torpedoes that homed on propeller noise, and enhanced anti-aircraft armament for surface combat against patrol aircraft. These improvements extended U-boat survivability but could not overcome the fundamental shift in the tactical balance. By late 1943, operating a U-boat in the North Atlantic had become a suicide mission. Of 40,000 men who served in German U-boats during the war, 30,000 died. The 75% casualty rate was the highest of any military branch in any nation during World War II. German submarines continued operations until May 1945, but after mid-1943, they represented a strategic nuisance rather than an existential threat to Allied logistics. The Japanese submarine force entered the war with comparable technology and superior torpedoes, but fundamentally different doctrine. Japanese submarines were designed and employed as fleet auxiliaries intended to weaken enemy naval forces before decisive surface engagement. Japanese submarine commanders were instructed to prioritize attacks on warships, particularly aircraft carriers and battleships. Merchant shipping was considered a secondary target of limited strategic value. This doctrinal choice reflected Japanese naval planning assumptions that the war would be decided by a climactic fleet engagement similar to the Battle of Tsushima in 1905, where the Japanese combined fleet had annihilated the Russian Baltic Fleet. Japanese submarines would contribute to victory by reducing enemy fleet strength before battle. The doctrine was strategically incoherent in a Pacific War where distances made decisive fleet engagement unlikely, and where American industrial capacity made attacking production infrastructure more valuable than attacking individual warships. Japanese submarines achieved notable successes against American warships, including sinking the carrier Wasp and damaging the carrier Saratoga. But these tactical victories had minimal strategic impact because American shipyards were producing replacement carriers faster than Japanese submarines could sink them. Meanwhile, American merchant ships traveled throughout the Pacific, delivering raw materials, finished goods, food, fuel, and military equipment with minimal interference from Japanese submarines that were occupied hunting warships. The American submarine force began the war with obsolete doctrine, defective torpedoes, and inadequate training, but possessed the institutional flexibility to learn and adapt. American submarine doctrine in 1941 emphasized caution, defensive operations, and strict adherence to prize rules requiring surfacing to warn merchant vessels before attack. These doctrinal limitations reflected American adherence to international law regarding submarine warfare and a cautious command culture that prioritized submarine preservation over aggressive operations. The attack on Pearl Harbor eliminated any remaining American inhibitions about unrestricted submarine warfare. On December 7, 1941, Chief of Naval Operations Admiral Harold Stark issued orders authorizing American submarines to conduct unrestricted warfare against Japanese shipping without warning. The order represented a fundamental policy shift that would shape the entire Pacific submarine campaign. However, doctrine meant nothing when torpedoes failed to function. The Mark 14 torpedo that equipped American submarines in 1941 suffered from 3 critical defects that rendered it largely ineffective. The depth control mechanism caused torpedoes to run approximately 10 feet deeper than set, causing them to pass harmlessly beneath target vessels. The magnetic influence exploder designed to detonate the warhead when passing beneath a ship's hull was hypersensitive and frequently caused premature detonation before reaching the target. The contact exploder was too fragile and would crush rather than detonate when striking target hulls at steep angles. These defects were not theoretical possibilities, but consistent problems documented by submarine commanders throughout 1942 and early 1943. Commander after commander reported perfect attack geometry, proper target tracking, accurate firing solutions, and torpedoes that either missed, exploded prematurely, or struck targets without detonating. The Bureau of Ordnance refused to acknowledge torpedo defects despite overwhelming field reports documenting failures. Bureau officials insisted that torpedo performance met specifications and that reported failures resulted from improper submarine handling or commander error. The institutional resistance to acknowledging torpedo defects reflected bureaucratic defensiveness, personal career investment in torpedo development programs, and genuine technical confusion about failure mechanisms that could not be replicated in controlled testing environments. The controversy continued until submarine commanders conducted unauthorized field tests that conclusively demonstrated each defect. In one famous incident, Commander Lawson Ramage conducted repeated attacks against a stationary hulk, carefully documenting each torpedo failure, and forwarded the results directly to Admiral Charles Lockwood, Commander Submarines Pacific, bypassing the Bureau of Ordnance entirely. Lockwood used his command authority to authorize modifications to torpedo depth settings and to deactivate magnetic exploders, effectively overruling Bureau of Ordnance objections. These field modifications, implemented in mid-1943, immediately improved torpedo effectiveness. Successful attacks increased dramatically as torpedoes began running at correct depths and detonating on contact, rather than passing beneath targets or exploding prematurely. The contact exploder problem persisted until September 1943, when Lockwood authorized complete redesign of the firing pin mechanism based on field testing that demonstrated the crushing failure mode. Once all 3 defects were corrected, American torpedoes became reliable weapons that functioned as designed. The timing proved catastrophic for Japan. American submarines began operating with reliable torpedoes precisely when Japanese merchant shipping losses were becoming critical to war production. Throughout 1942 and early 1943, Japanese merchant losses were sustainable despite steady attrition. Japanese shipyards were constructing replacement tonnage at rates that approximately matched losses. The balance was precarious but maintained equilibrium. In late 1943, that equilibrium collapsed. American submarines equipped with functioning torpedoes and increasingly aggressive commanders began sinking Japanese merchant ships at rates that exceeded replacement capacity by widening margins each month. The statistics documented the destruction with precision. In 1942, American submarines sank 180 Japanese merchant ships, totaling 725,000 tons. That represented approximately 5% of Japan's total merchant fleet and was easily replaced through new construction and captured vessels from occupied territories. In 1943, American submarines sank 284 merchant ships, totaling 1.3 million tons. Japanese shipyards produced approximately 800,000 tons of new merchant shipping that year, creating a deficit of 500,000 tons that reduced total fleet capacity. In 1944, American submarines sank 603 merchant ships, totaling 2.7 million tons. Japanese construction that year totaled approximately 1 million tons, creating a net loss of 1.7 million tons that crippled industrial production throughout the empire. The cumulative effect was starvation of Japanese industry. Oil tankers traveling from the Dutch East Indies to Japan became primary targets for American submarines operating along established shipping routes. Tankers were large, slow, difficult to defend, and absolutely critical to Japanese operations. Without oil from Sumatra and Borneo, Japanese industry could not function. Aircraft could not fly, ships could not sail, tanks could not move. Every tanker sunk represented thousands of tons of oil that would never reach Japanese refineries. By late 1944, oil shipments to Japan had declined by 70% from 1942 levels, despite desperate Japanese efforts to maintain tanker traffic. Iron ore presented similar problems. Japanese steel mills imported ore from China, the Philippines, and Malaya. Ore carriers were vulnerable to submarine attack throughout their routes. As ore shipments declined, steel production fell. Reduced steel production constrained every aspect of Japanese war production, including aircraft manufacturing, ship construction, ammunition production, and vehicle assembly. The cascading effects rippled through the entire economy. Food imports declined as cargo ships were diverted to military purposes or sunk by submarines. Rice imports from Southeast Asia that fed Japanese cities dropped to 30% of pre-war levels by 1945. Urban populations faced genuine starvation that was only partially mitigated by draconian rationing and forced agricultural expansion. The human cost of the submarine campaign extended beyond military casualties to include Japanese merchant mariners who suffered appalling losses. Approximately 122,000 Japanese merchant sailors served during the war. Approximately 60,000 died, yielding a casualty rate approaching 50%. These sailors faced submarine attacks without the defensive capabilities available to military vessels, sailed in ships that often lacked lifeboats or survival equipment, and received minimal training in damage control or emergency procedures. When a merchant ship was torpedoed in the Pacific, survival rates were low because rescue operations in contested waters were impossible, and because many ships sank so quickly that crews could not launch boats or don life preservers. American submarine commanders faced ethical dilemmas about survivors. International law required submarines to provide for survivor safety when possible, but surfacing to rescue survivors exposed submarines to counterattack from escort vessels or patrol aircraft. Most commanders adopted pragmatic policies of attacking ships, but not deliberately targeting survivors. Some commanders surfaced to provide survivors with navigation information or medical supplies before leaving the area. Others documented survivor positions through radio reports to neutral vessels or Japanese authorities. A few commanders engaged in deliberate targeting of survivors, actions that violated international law and American naval regulations, but went largely unpunished during wartime. The submarine campaign against Japan succeeded because it exploited fundamental vulnerabilities in Japanese maritime logistics while avoiding the technological and tactical countermeasures that defeated German U-boats in the Atlantic. Japan entered the war with inadequate merchant fleet capacity for its strategic requirements, possessed minimal anti-submarine warfare capabilities, and failed to implement effective convoy systems until losses had become catastrophic. The combination created conditions where American submarines operated with relative impunity throughout much of the war. Japanese merchant fleet capacity in December 1941 totaled approximately 6 million tons, including requisitioned civilian vessels. This represented barely adequate capacity for peacetime trade requirements and insufficient capacity for wartime needs that included supplying military forces across the Pacific, maintaining industrial imports, and feeding the population. Japan captured approximately 1 million tons of Allied merchant shipping during its initial conquests, providing temporary relief, but these gains were quickly offset by operational losses and submarine attacks. Japanese anti-submarine warfare in 1941 was rudimentary compared to British or American capabilities. The Imperial Japanese Navy possessed approximately 300 escorts and patrol vessels capable of anti-submarine operations, but most were obsolete destroyers or converted fishing vessels with minimal detection equipment and inadequate armament. Japanese depth charges were less powerful than Allied weapons. Japanese sonar was inferior to American or British equipment. Japanese escort doctrine emphasized formation protection for military convoys rather than persistent prosecution of submarine contacts. The result was defensive posture that allowed submarines to attack, dive, and escape with minimal risk of sustained pursuit or destruction. Japan recognized these deficiencies as losses mounted, but could not implement improvements fast enough to offset American submarine effectiveness. Japanese shipyards constructed escort vessels throughout the war and eventually produced approximately 800 anti-submarine capable ships. However, these vessels were dispersed across vast ocean areas, lacked coordination with air assets, and employed tactics that proved ineffective against American submarine operations. Japanese escort commanders typically responded to submarine attacks by dropping depth charges near the last known contact point, then returning to convoy protection duties rather than maintaining contact and prosecuting the attack until the submarine was destroyed or conclusively driven off. The failure to implement effective convoy systems until 1943 magnified Japanese losses unnecessarily. Britain had established convoying as standard practice in 1917 during World War I after learning that grouping merchant ships with escort protection dramatically reduced submarine effectiveness. The United States implemented convoying immediately after entering World War I and maintained convoy doctrine throughout the interwar period. Japan inexplicably failed to adopt systematic convoying until losses forced recognition that independent routing was unsustainable. Even after implementing convoy systems in 1943, Japanese convoys were smaller, slower, and less well protected than Allied convoys in the Atlantic. The geographic realities of the Pacific War favored submarine operations. Japanese shipping routes from Southeast Asia to Japan passed through relatively constricted choke points, including Luzon Strait, Formosa Strait, and approaches to major ports where submarines could concentrate, knowing that targets would eventually appear. The vast distances involved meant that aircraft patrols could not provide continuous coverage. Japanese air assets were allocated primarily to combat operations rather than anti-submarine patrol. This created large ocean areas where submarines operated without air threat, allowing them to surface freely to recharge batteries, navigate, and transit between patrol areas at higher speeds. American submarines also benefited from superior intelligence that provided advance warning of convoy schedules, routes, and compositions. American cryptanalysts had broken Japanese naval codes by mid-1942, providing submarine commanders with detailed information about merchant ship movements. Code-breaking intelligence was supplemented by coast watchers throughout the Pacific, who reported ship sightings, photo reconnaissance that documented port activities, and traffic analysis that revealed patterns in Japanese shipping operations. This intelligence advantage allowed American submarines to position themselves along projected convoy routes rather than conducting random patrols hoping to encounter targets. The contrast with German U-boat operations in the Atlantic was instructive. German submarines faced continuous air coverage over many convoy routes, sophisticated sonar and radar detection systems, highly trained escort groups employing aggressive prosecution tactics, and convoy systems that had been refined through years of operational experience. American submarines in the Pacific faced minimal air threats over most patrol areas, rudimentary Japanese detection systems, escort groups that employed passive defensive tactics, and convoy systems that were implemented late and never achieved Atlantic convoy effectiveness. American submarine construction rates ensured that losses could be sustained while maintaining offensive pressure. The United States constructed 203 fleet submarines during the war using standardized designs that simplified production and maintenance. The Gato and Balao classes represented incremental improvements on proven designs rather than revolutionary innovations. This design conservatism accelerated production and ensured reliability. American submarines were mechanically dependable, could sustain extended patrols lasting 60 to 75 days, and possessed habitability features that maintained crew effectiveness over long deployments. Japanese shipbuilding priorities limited merchant construction in favor of warship production. Japanese industry constructed approximately 4 million tons of merchant shipping during the war, far less than the losses sustained. The deficit reflected strategic decisions to prioritize battleship, carrier, and destroyer construction over merchant vessel production. Japanese naval leadership remained focused on achieving decisive fleet engagement rather than protecting logistics infrastructure. This strategic misallocation ensured that merchant fleet capacity declined throughout the war, regardless of operational successes or failures in individual battles. The human dimension of submarine warfare included extraordinary bravery and grueling conditions on both sides. American submariners operated in cramped, humid, mechanically intensive environments for extended periods with minimal contact with friendly forces. They faced depth-charge attacks that tested psychological endurance as explosions bracketed their vessels while they waited silently at depth, hoping to avoid detection. They dealt with mechanical failures, navigational challenges, and the constant stress of operating independently in enemy-controlled waters. The submarine service attracted volunteers who were generally more educated and technically proficient than average naval personnel. Training was extensive and selection standards were high because submarine operations required technical competence and psychological stability. Japanese merchant sailors faced different but equally severe challenges. They served on vessels that were increasingly dangerous as the war progressed. Early in the war, merchant service was relatively safe because submarine attacks were infrequent and many routes remained secure. By 1944, boarding a merchant ship bound for Japan represented accepting substantial risk of death or injury from torpedo attack. Sailors understood these risks, but had minimal options for refusing dangerous assignments. Many were conscripted into merchant service. Others volunteered from patriotic duty or economic necessity. The deteriorating conditions included inadequate food, minimal medical care, overcrowded berthing, and psychological stress from constant awareness that submarine attack could occur at any moment. The strategic impact of the submarine campaign manifested in Japanese war production statistics. Japanese aircraft production peaked in 1944 at 28,000 aircraft, despite American strategic bombing that had not yet reached full intensity. Production declined in 1945 not primarily because of bombing damage, but because aluminum imports required for aircraft manufacturing had ceased due to loss of shipping. Japanese shipyards launched their last aircraft carrier in October 1944 and their last battleship in November 1944. Subsequent construction focused on destroyers and escorts because material shortages prevented building larger vessels. Japanese ammunition production declined by 40% in 1945 because copper imports for shell casings had stopped. Food riots occurred in Japanese cities throughout 1945 as rice imports fell to levels insufficient to feed urban populations even with strict rationing. These material shortages directly resulted from submarine interdiction of merchant shipping. The submarine campaign achieved what strategic bombing sought to accomplish with far fewer resources and lower casualties. Approximately 16,000 American personnel served in submarines during the Pacific War. 52 submarines were lost to all causes, including combat, accidents, and mechanical failure. Approximately 3,500 submariners died. This represented approximately 2% of American naval casualties during the war, yet submarines sank 55% of all Japanese merchant tonnage lost during the war, and 30% of Japanese naval vessels sunk. The efficiency ratio was extraordinary. each American submarine sank an average of 13 merchant ships during the war. Individual high-performing submarines exceeded 40 vessels sunk. Commander Richard O'Kane in USS Tang sank 33 ships before Tang was sunk by a circular run of its own torpedo in October 1944. Commander Eugene Fluckey in USS Barb sank 17 ships and conducted shore bombardment missions against Japanese installations. Commander Samuel Dealey in USS Harder sank 16 Japanese escort vessels in addition to merchant ships and became legendary for aggressive tactics against anti-submarine forces. These commanders and dozens like them developed tactics, trained crews, and prosecuted attacks with effectiveness that far exceeded pre-war expectations. The Japanese response to submarine warfare demonstrated organizational inflexibility and strategic confusion. Japanese naval authorities recognized the merchant shipping crisis by 1943 but implemented inadequate countermeasures. Convoy systems were established but never received sufficient escort allocation to be effective. Anti-submarine warfare remained a low priority for resource allocation even as losses mounted. Technological improvements, including sonar and radar, were developed but deployed too slowly to affect outcomes. The fundamental problem was that Japanese naval doctrine remained focused on decisive fleet engagement rather than maritime logistics protection. This doctrinal rigidity persisted even as evidence accumulated that logistics was determining the war's outcome. Some Japanese naval officers recognized the problem and advocated for strategic reorientation toward defensive operations and logistics protection. These advocates remained marginalized within a command structure dominated by officers who viewed defensive operations as shameful and who continued planning for offensive fleet actions that material constraints made impossible. The result was continued emphasis on battleship and carrier operations through 1944, even though fuel shortages made operating these vessels increasingly difficult. Japanese submarines continued hunting American warships even though American merchant ships represented more valuable targets. Japanese escort forces remained scattered and ineffectively employed even though concentrating anti-submarine forces along critical routes might have reduced losses. The comparison with German U-boat operations revealed that submarine effectiveness depended on targeting vulnerability rather than submarine technology or crew quality. German submarines were technologically sophisticated and operated by highly trained crews, yet they failed to achieve strategic success against Allied merchant shipping because Allies implemented effective countermeasures, including convoy systems, air coverage, improved detection equipment, and aggressive prosecution tactics. American submarines were less technologically advanced than German U-boats in several respects, including diving depth, underwater speed, and snorkel capability, yet they achieved far greater strategic impact because Japanese countermeasures remained inadequate throughout the war. The lessons extended beyond World War II to fundamental principles of maritime strategy. Island nations and economies dependent on maritime trade remain vulnerable to submarine interdiction regardless of military superiority in other domains. Effective convoy systems supported by adequate escort forces and air coverage can reduce submarine effectiveness but require substantial resource allocation and sophisticated coordination. Submarine forces operating against opponents lacking effective anti-submarine capabilities can achieve strategic effects disproportionate to their numbers. These lessons shaped Cold War naval planning and remain relevant to contemporary maritime strategy. The human legacy of the submarine campaign included survivors who carried psychological scars for decades. American submariners who survived depth charge attacks described the terror of waiting silently while explosions shook their vessels and the relief when attacks ended and they could surface safely. Japanese merchant sailors who survived torpedo attacks described watching ships sink with hundreds of crewmates trapped below decks and the desperation of floating in open ocean awaiting rescue that often never came. The traumatic experiences shaped the remainder of their lives, even for those who never discussed their wartime service publicly. The strategic outcome was decisive. By August 1945, Japanese merchant fleet capacity had declined to approximately 1.5 million tons from the 6 million tons available in December 1941. This represented a 75% reduction that rendered Japan incapable of sustaining industrial production or feeding its population. Oil imports in August 1945 were effectively zero because no tankers could survive the passage from Southeast Asia to Japan. Food imports had declined to levels requiring caloric intake reductions that approached starvation for urban populations. Industrial production had collapsed because raw material imports had ceased. The submarine campaign had achieved its strategic objective of economic strangulation without requiring invasion or strategic bombing alone to force surrender. The title of this analysis suggests Germany sank 2,800 ships, while America built 2,700 ships in 1 year, and Japan starved. The actual numbers vary by source and counting methodology, but the pattern holds. German U-boats sank approximately 3,000 Allied merchant ships during the entire war. American shipyards built approximately 5,000 merchant ships during the war, including 2,700 Liberty ships and Victory ships constructed in 1943 alone. American submarines sank approximately 1,300 Japanese merchant ships. Japanese shipyards built approximately 4 million tons of replacement merchant shipping. The ratio between losses and construction determined outcomes. Allies replaced submarine losses faster than Germany could sink them. Japan could not replace submarine losses and gradually starved. The admiral standing in Tokyo in November 1943, studying red pins on a map, understood this arithmetic. Each pin represented not just a sunken ship, but also thousands of tons of cargo that would never reach Japan. Oil that would never fuel aircraft. Iron ore that would never become steel. Food that would never feed workers. The pins accumulated month by month, marking the methodical destruction of Japan's ability to sustain the war. By November 1944, the WWII map would be covered with pins so densely packed that individual losses could not be distinguished. By August 1945, the merchant fleet would be functionally extinct, and Japan would surrender because continuing the war had become physically impossible. The submarine campaign achieved this outcome through persistent application of force against economic vulnerability, rather than through spectacular victories or technological breakthroughs.